So we talked about data and its home, databases. But there are not only a single type of database in the world. Now I will introduce you different types of databases. Some of them are in the history now, but some of them are still in use. Let's begin. So let me introduce you, first of all, there is a time in humanity that we had softwares, we have the systems, but we didn't have any databases. During that time, generally, the GUI, the graphical user interfaces of the softwares were just like the ones you see on the screen. Okay, you couldn't use mouse. You had to use these arrows to do something. The usability was very low, etc. And during this period, the software developers were responsible for storing the data and processing the data. They were not only designing the GUI, the graphical user interface. They were not only designing the application part, the rules, etc. They were also designing all the data-related operations, just like storing data, getting a report, making calculations, etc. But in a short period of time, it was observed that operations related with the data were very limited. Indeed, at the end, they were doing a specific job, and if the software developer is not capable on it, it costs lots of inefficiency. For example, during that time, instead of databases, the software developers used Notepad kind of word processors. So when you want to create a record about a phone call, for example, during this time, comma, this person called, comma, from this phone number, comma, and this amount of talk was done. Okay, they separated the data with commas and write it down in a notepad form of word processor. And when another entry comes, they enter it to the second line, then to the third line. And if the number of phone calls increase, this means you have a huge notepad, and when you need to make an operation on it, it becomes very hard, because first you need to read all the files, then you need to find the related entries, then you need to get the part you will use and make your calculations. It became very inefficient. So, in a small period of time, a specific software just for keeping data and making data-related operations was developed. And the first one was hierarchical model. It was just like before starting your information system development, software development, you focused on data and what kind of a data will I have. You model it in a software, then you used it. It was something like this. But it was not flexible, because in the first model, in the hierarchical model, it was just like a tree. A parent could have lots of child, but each child could have only one parent. This relationship was very restrictive, so it didn't become very effective. Then the model is changed to a network model, in which the relationship between parent and child was cleaned, so every data node could be in relation with another one. But still, it was not flexible enough, because in the information systems, when you develop it, in any moment there can be new needs. You need to update the data. It was not suitable for this kind of agile adaptation. So network model is not being used today. In the timeline, object-oriented model comes after, but now I want to mention it because it is not being used. So maybe some of you have heard the word object-oriented design, object-oriented software development. It is a software development perspective which focuses on creating classes and creating objects out of classes. So basically, instead of dealing with variables, you deal with objects. So in software development, it is something wonderful. And in the database part, the main idea was to use this object-oriented software development perspective in databases. But it didn't work out. So today, this kind of databases are not being used. So you don't need to know much about them. Up to this point, we talked about hierarchical network and object-oriented model. Next, what we have is the relational model. This type of database is the database that is used in 99% of all information systems. So this is the dominant database model we have today in the world. It is not new. It is in use for last 30 or 40 years. But the main idea is the same. But of course, there are some changes in the infrastructure, so it becomes effective every year in every new version of the software. In our course, when I say database, please understand the relational databases. The scope of this course is the relational databases. So what is relational database? Let me tell you that we will talk a lot about it, but I'm just giving a brief introduction. It keeps data in tables, just like the tables you have in your Excel or in your Word software. So you have columns, you have rows. The main idea is just like this. But the important issue here is that there is a design rule or design perspective in relational databases. Each table must be designed to define an entity, an object. Okay, let's say classrooms or students or instructors. They are all different objects or all different users of a system. Then, if you want to define a student, you have a table for it. If you want to define an instructor, you have a table for it. Let me check. You have a table for all instructors, and each single instructor becomes a line or a row on that table. So if you have a students table, okay, then each student is written into a single row. So if you have 10 students, then there must be 10 rows. If you have 3 instructors, you must have 3 instructors. And the columns are the properties of these entities. So, for example, what property you want to keep about instructors? Most probably it's name, surname, phone number, email address. Okay, these are the important properties you want to keep. So you make these properties a column in the table. So first name column, last name column, email column, phone number column. It works like this. Why it is flexible when compared to the previous ones? Because at any time, if you need a new property, for example, we didn't talk about an instructor's postal code. We didn't talk about it. We talked about other 4 properties. But suddenly you understand that you need this data. then you just open a new column on that table. That's all. And you open the column, then fill the cells. That's all. And if you have a new instructor, assume that you were working with 3 instructors, then you have the 4th one. You just open a new row. So the table perspective is very flexible. If you need new property, add a column. If you have a new observation or a new instructor, a new student, just open a new row. That's so simple. Besides, this is the flexible table. I talked about the flexibility of a table. Besides this, relational databases can join tables. If they have some common data, they can build a bridge between tables. So let's take a look at the picture here on your screen. Here in the database 1, we have 3 John Smiths and we have social security numbers. And in database 2, we have birth of date or date of birth and social security numbers. And here we have address and social security numbers. The social security numbers are common. So you can easily find which John Smith lives in which address and when he was born. Just like here, you can see the second John Smith is born in 1940, and he lives in Monroe Avenue. How I found it? Because we have this social security number here, the same here, and the same here. That's so simple. So we did it with our eyes and with our mind. We matched the data and find out which John Smith lives where, etc. The good news about relational data model is that using SQL language, which I mentioned before, you can make this operation, matching operation, automatically. So in another perspective, you can have lots of tables, but if you have a common data, you can bind them and behave just like they are integrated. You can get reports immediately. You don't need to match the common data by yourself. Okay, this is John Smith. Let's take a look at its social security number. Oh, it's over here. You don't need to do anything like this. You just write down some SQL commands and you get the result. It is so easy. This is what a relational data model is. And let me repeat. First, when I say database in this course, I mean relational databases. And this is the most common database in the world. So it is not something new like generated in the last decade, but it is still very common and it will be common in the near future. That's why it is something important. But it is not all what we have here. In the world of big data, there are different data needs. So, for example, when you think about Facebook or social media, you are generating a content and it is distributed to millions of people, or it can be distributed. And it is done in milliseconds. You need to be effective and you need to work very quickly in database perspective. So in this new data area or the big data part, there are new database types which are called under the name of NoSQL. SQL, as you can remember, stands for SQL, but NoSQL means not only SQL. It is not like, okay, we are objecting to SQL, we don't like it, we are better than it. It doesn't say anything like this. It says there is another type of databases which doesn't use SQL. Okay, so NoSQL is not a database type. It's a group name. There are different database types under this group. So what we have here is that there are in some different resources, different numbers can be given, but these are the most commonly used NoSQL databases. Let me explain. Key value stores, as you can see in the graphic, it is only a table with 2 columns. That's it. No other table, no other column, only 2 columns. You enter the data with a key, you give the key, you give the value, you store data just like this, and when you want a value, you give the key and you get the value. That's it. Okay? So simple, but it is effective because it is very fast. The second one is the column family or column-based store. It is just like key value store, but it has other columns. But it looks like a table, but it's not a table indeed. When you make a query, it reports you just like a table, but at the background, it's not a table. It has a different infrastructure. So it is not like the tables we have in relational databases. It is a very big table, but you cannot join a data with another table. So what you can do with it, you can model your data in a single huge table. That's it. And here we have Cassandra and HBase as an example. And the third one is the document-based store. It is just like a database, but indeed it is not a database like the others because the data are stored in a document. A document, here we mean the documents written in JSON or XML, a specific type of coding or the type of storing data. The important thing about this document-based store is it can store very long documents, and documents are independent from the others, so it is very flexible. And the last part is the GraphDB, and GraphDB is more about making queries about the links between data. It is not like asking what is the surname of Ali, but it is just for queries like how Ali and Aisha is related. And you can get results like Ali is a friend of Efe. Efe is working in or a student in Istanbul Technical University, and Aisha is also a student in Istanbul Technical University. So in graph databases, you define data points and you also define how these 2 points are linked and make search using these links. Maybe you see you already saw some queries like you search for Coca-Cola in LinkedIn and it gives you a path. It says your friend works in a company and his friend works in another company and his brother works in cola. So there's a link between you and Coca-Cola like this. If you want to make search about the links between data, you can use graph databases. As a summary, this is just a brief introduction. SQL is just like the cars we have on our street. There are different brands, but generally they do the same thing. But for specific cases, there are different types of cars, like racing cars, etc. NoSQL databases are representing these specific cars. For example, Formula 1 car is fast, but you cannot ride it in Istanbul because the roads are not suitable. Okay, so it is not like F1 car is better than our car on the street, or is better than Tesla. You cannot compare it because they work under different situations, okay, under different circumstances. So for general purpose, we have SQL. For specific purposes, we have NoSQL databases. It is not like NoSQLs are better than SQLs. And in the near future, we will still have SQL and we will still have NoSQL. The important misunderstanding about our course is like this. NoSQLs are new, so the old one, SQL, is bad. It is not like this. Forget it. SQL is good. SQL is something very popular today, and it will become popular in the near future also. So everybody will still use SQL databases. So I made an introduction to different databases. Now we will go on into details of relational databases.